All right, in equation, or in problem number 4, it says the derivative of the function is given by the function f prime of x is cosine of x squared. Use a calculator to find the values of x on the interval from negative pi halves to pi halves such that f is increasing. Okay, so first thing we need to do is take our derivative. We need to set it equal to 0. Okay, so even though this is a calculator question, on the AP exam, what they would like to see is that you actually set the derivative equal to 0. You can either say the cosine of x squared is equal to 0, or you can say f prime of x is equal to 0. By doing that, the AP reader knows that you are now going to use your calculator to graph and find the zeros. So if we graph the function, okay, and we only need to look on the interval from negative pi halves to pi halves, we are going to be looking for the 2 zeros. And so we could use that second calc 0 option to find the 2 zeros. So the answer to this question would be the critical points are at x is equal to positive or negative 1.253. List your answers with 3 decimal places always, and the third decimal place can be truncated or rounded. Okay, so these are the critical points, but now we want to make sure we answer the question, when is the function increasing? So we can look at the graph and see that this is happening, but on a corresponding number line, what I'd be looking at are the 2 critical points and the endpoints, so I know that I don't need to look beyond those. Okay, and we can see that the graph is negative to the left of negative 1.253, positive between, and negative to the right. So in answering the question, f of x is increasing on the intervals, or on the interval, negative 1.253 to 1.253. Okay. Question 5. The graph of f prime, the derivative of the function f, is shown. Find the relative extrema of f and justify your answer. Okay, so this is the first question where I've seen the words justify your answer. So pay attention to how we do that. All right, so if I want to find relative extrema, I'm going to consider all critical points. So looking at this function, this derivative, f prime of x is equal to 0. At x is equal to negative 2 or positive 3. Okay, organizing my thoughts through a number line, sign pattern number line. I know the derivative is 0 at negative 2 and at positive 3. I know the derivative is positive to the left of negative 2. Therefore, my function is increasing. I know the derivative is negative in between negative 2 and 3, therefore my function is decreasing. Positive to the right of 3 for my derivative, so my function is increasing. Okay, so from this number line, I can tell, since my curve is going up and then down, there must be a relative maximum at x equals negative 2. The relative extrema coordinate would be negative 2, f of negative 2. And this is because f prime changes sign from positive to negative. at x equals negative 2. Okay, continuing on, looking at the number line, the function is decreasing and then increasing. Therefore, at x equals 3, the graph has a relative minimum. The coordinate of the relative extrema, the relative minimum, would be 3f of 3, because, and I know it's a minimum because f prime changes sign from negative to positive. Okay, so when we say these things, f prime changes sign from positive to negative or from negative to positive, all right, we are using the first derivative test. All right, and the first derivative test is a way to justify your answer. Okay, let's take a look at problem number 6. Find the relative extrema of this cubic polynomial. This time it says they want us to use the second derivative test and no calculator. Okay, so the second derivative test, remember, has to do with concavity. So if a graph is concave up, meaning the second derivative is positive, but there is, second derivative is positive, but the derivative is equal to 0, okay, at that particular value. Okay, so if the second derivative is positive at x equals c, but the first derivative is 0 at x equals c, then we know there must be a minimum. Okay? Likewise, we could do the same for the maximum. So let's take a look. F of x is given. Let's find f prime of x. So that would be x squared minus 2x minus 3. All right, this first derivative factors into x minus 3 and x plus 1. So this function has critical points at x equals 3 and x equals negative 1. Okay, so just using the first derivative test, I could make a number line and decide where we're increasing and where it's increasing and decreasing, and then answer the question about maxes or min. But they want us to use the second derivative test. So let's go ahead and take the second derivative. And I'm going to come back to this form. So 2x minus 2. I'm going to look to see when the second derivative is equal to 0. That happens when x is equal to 1. So they don't often call it this, but this is a critical point on the second derivative. Okay? All right. Oh, I apologize. I don't actually need to find this, right? This would lead to an inflection point. What I want to do is I want to use the second derivative and the critical points from the first derivative to decide what kind of extrema is happening at x equals 3 and x equals negative 1. So let's do f double prime of 3 and f double prime of negative 1. Okay, so here we go. F double prime of 3 would be 6 minus 2 or 4. That's greater than 0. Therefore, f of 3 is, that's a concave up, is a relative min. Okay. F double prime of negative 1, is going to be -4, which is less than 0. Therefore, f of -1 is a relative max because the graph is concave down. Okay. All right, moving on. Find the relative extrema of x squared minus 1 to the 2/3. Use the first derivative test and no calculator. Okay, so first take the derivative. We're going to get 2/3 x squared minus 1 to the -1/3. Rewriting this so it has that positive exponent instead of negative. Oops, that should be a 1/3. Okay, and I'm also going to factor the denominator. Okay, so I can see very clearly from that algebraic work that f prime of x equals 0, never, and f prime of x is undefined when x is equal to positive or -1. Okay, we'd like to use the first derivative test to verify maxes and mins. So let's start with our sign pattern number line, putting our critical points of -1 and +1 on the number line. Let's decide what's happening on the derivative on each of these intervals. So if I plug -10 into this derivative, all right, we're going to get a negative and a negative. Multiplied together would be positive. Cube root of positive is positive. Multiplied by 2/3, positive. Okay, so it's positive to the left. All right, in between -1 and 1, let's test 0. So plugging in 0, that's going to turn out to be a negative times a positive in the denominator. That will be a negative. The derivative will therefore be negative in between -1 and 1. Let's do a positive 10. This will be positive. This will be positive, these two factors. So that's a positive in the denominator, positive in the numerator, so it's positive. Remember my earlier example of let's take a look at the related polynomial. This polynomial crosses the x-axis at 1 and -1, and it's positive, negative, and positive. So this is not the graph of my function, nor is it the graph of my derivative, but it is a related polynomial, which quickly tells me the positiveness or negativeness of my derivative. Okay? All right, so I know my function is increasing, then decreasing, then increasing. So let's answer the question. Find the relative extrema, and I'm going to also say justify. The more you start justifying, the more natural it will be, and then there will not be a question about why you have come to your conclusions. Okay, so we're going to say f of -1 is a relative max because f prime changes sign from positive to negative. Half done. Okay, f of 1 is a relative min because f prime changes sign from negative to positive. Okay, we've answered the question. I'm going to stop there. We have got 3 more questions left, and I'll do one more video on the wrap-up of 4.1, 4.2 notes.